Good afternoon, students. Today in class you learned section 4.7 on similar polygons, and now I'm going to take the opportunity to go over a few extra problems and extra examples with you. So we will take some time to do that. Here are the notes that you were given in class in case there were some of those that you did not have an opportunity to get down at that point in time. And remember, you can always hit pause if there's something that you need to copy down. Some of the simple vocabulary words are listed here, but first our essential question. How do I determine if polygons are similar? And if they are, how do I find the missing side lengths if they're not listed? First, it would be helpful to know what a polygon is. A polygon is a shape that is made of segments that are connected to form a closed figure. What does it mean to be a closed figure? Well, that's not closed. So that's not a polygon. Now it is closed. Now it is a polygon. If polygons are similar, they have the same shape, but they could be different sizes. Now there's no way I'll recreate this shape, but it would be like having a circle and another circle. They're similar, but they're not exactly the same. If I have corresponding parts, they're parts that are on the same side. So really simple, if I was to draw two triangles, this side is the same as this side. If I was to draw two rectangles, notice that these rectangles are flipped, but this side would be the same as this side. Excuse me for 1 minute. If I have something that is congruent, they're the exact same shape and same size, so a little bit different than similar, same shape and same size. Scale factor is the ratio or fraction of the lengths of two sides that are corresponding, so it'd be like a fraction of these two sides. All right. Right away, we have to start with what two sides are congruent. The first thing that we need to look at are the angles. That's the easiest part to look at. I here notice that this angle has two little hash marks, two little curves. What that is telling me is that this angle has the same measurement as another angle in this figure. Well, it's going to be the one that has two hash marks again, or these two little curves. So that tells me that angle E from this triangle is congruent to, we use this little silly symbol here, is congruent to angle F on the other. Angle D does not have any kind of hash marks at all. So if I look over here and see which one doesn't have any kind of hash marks, well, it's angle B. So it's congruent to angle B. Now, the directions say to state which sides are congruent. So I'm going to, maybe I can highlight here. I'm going to highlight this side. When I highlight this side, what I want to look at is the fact that it starts off on, we started up here. We started with letter E, and we went down to A. We have the segment E to A. 2 marks to 1 mark. So I'm going to come over here and look, and I want to look for where do I have 2 marks to 1 mark. Well, here's 2 marks. So I'm going to start here, and I'm going to go this way to 1 mark. 2 marks to 1 mark here is F to C. So side EA is congruent to side FC. Let's try another one. Let's go from 2 marks to no mark. 2 marks was letter E to no mark, letter D. So ED is congruent to, on this side, 2 marks, starts here, to no mark, B, F to B. They are congruent. Take some time and see if you can figure out the last one. What I want you to notice is that I did not switch these around. It could not be BF, has to be FB. All right, let's look at an example here where we have to set up some numbers. The first thing I want to do is compare the angles. Well, all of these are right angles. So it tells me that all the angles are congruent. K is congruent to N, L is congruent to M, because this is a long side, short side, short side. I know that I could fill in a 6 here and a 10 here. I could fill in a 3 here and a 7 here just due to the properties of this particular polygon. Now it says if you can compare the angles for congruence first, do that. I did. I could say that angle L is congruent to angle M and some others. Step 2, I need to compare the sides to see if they are proportional. Remember from the last lesson, if sides are proportional, they have the same ratio. So what I need to do is compare the small shape, pick a side from the small shape, let's start with 7, and compare it to its corresponding side on the big shape. Well, what side corresponds to 7 is 10. So I will have 7 over 10. I'm going to go back to the small shape. It's a 3. And what side on the big shape corresponds to that is 6. Just like yesterday, we had to determine if these were proportional, if they were proportions. So the question was, do these equal? Remember, we could reduce, we could turn them into decimals, or we could cross multiply. If I cross multiply here, I get 30. And if I cross multiply here, I get 42. Are these two shapes congruent? And the answer would be no, they are not. They are not similar. They don't have congruence. All right, let's try another example. Let's see whether or not these are similar. First, let's check the angles. This angle matches this one. This angle matches that. This matches that. All right, so the angles match. Now let's check the sides. Again, what I want to do is take something from the small shape, put it over the big shape, and set that equal to small shape over big shape. Because remember from our ratios and rates lessons, I want to keep the same units. My small shape, this side is a 6. I have to pick the exact same side on the other one. So it's going to be an 8, or its corresponding side, I should say. Then I want to pick another one from small. I'll pick the 8. And the side on the big is a 12. Again, I can do two things here. I can cross multiply, or I can reduce. Let's try reducing. These are all nice even numbers. So 2 goes into here 3 times. 2 goes into here 4 times. 4 goes into 8 2 times. 4 goes into 12 3 times. It appears that they are not, but let's just double check. 4 times 2 is 8. 3 times 3 is 9. No, those are not similar, because we'd have the same proportions. So this would be no, because the proportions are different. Let's try another one. All right, first we need to list the corresponding angles. I'm going to say that angle D, here's angle D, has one little hash mark. So angle D corresponds to angle X, because there's one little hash mark. Angle A corresponds to, let's see, 1, 2, 3. Oh, it looks like this would be the answer because it's in the same spot, but it doesn't have the right amount of hash marks. So I'll have to come over here. 1, 2, 3. So it corresponds with angle W. I'm not going to finish listing these out, but you could. Now, let's list the corresponding sides. AC, side AC, 3 to 2, corresponds to 3 to 2. WZ. AB, 3 to nothing. AB corresponds to WY. BD, side BD, nothing to 1 is Y to X, corresponds to YX. Whoops, I don't know what I'm doing here. Hold on. Come to YX, it corresponds. And last but not least, DC, side DC, 1 to 2 corresponds to XZ. All right, those are our corresponding sides. This says to find the missing length. Well, this is missing and this is missing. So that's not going to help me much right here. What I think they want me to find is this m, because that's where the variable is. M is the same as yx right here. Its corresponding side was BD, 12. So I know that this would be like 12, and this would be like m. And I want this to be my small figure and this to be my big figure. So if I was to use my corresponding sides, I would have 12 over m for one of my ratios. 12 over m. And then I'm going to set that equal to any one of these other corresponding sides. It doesn't matter. I'll pick this one. DC was 10 over xz, which is 15. Now I need to find this missing side. We did this in class yesterday when we were working on that. All we have to do is cross multiply. I'm going to save myself a little extra work because I'm going to reduce this first. 12 over m equals 2 over 3. You ask how I did that? I just divided both of these by 5. It's going to make my multiplication a little bit easier here. All right, now I got to cross multiply. So 12 times 3 is 36. 2 times m is 2m, and they equal each other. Remember, we have to show all of our steps. So I'm going to rewrite my equation over here. What am I solving for? What's bothering it? How do the inverse? I'm going to find that my answer is 18. And this would be 18. So I was able to find that the missing side here would be 18. I am running low on minutes here, so let's just do some more examples. Small, I'm going to label this one as small and this one as big. I'm going to pick the long side of 3.5 and put it over the long side of 14, small side of 1.5 over the big side of 6. I can't think if these reduce right now, so I'm going to cross multiply, and I will get 21 over here. And if I cross multiply this way, I will also get 21. So are these two similar? Yes, they are, because their proportions are congruent. Scale factor. Scale factor is the same thing. Small over big equals small over big. Think about when they're going to build a new store. Recently, Cottage Grove had a new Walmart put in. They had a scale drawing of what it would look like. You could look at the whole store on paper, but that wasn't how big it was, because it was going to be much larger in real life. So on paper, they would have had some sort of conversion, some sort of unit, some sort of scale, kind of like when we talk about Matchbox cars. So in the Matchbox car, if on the small vehicle it's 1, and on the big vehicle it would be 64, I want to know if on the big vehicle, if it's 16 feet, how much is it on a small vehicle? Cross multiply and find your answer. That's all you would have to do here. Due to time, I want to go through, I don't have another example, so we can go ahead and finish this. So this would be 64x. This would be 16. So I would have 16 equals 64x. Remember that we were talking about feet here, so this is in feet. I'm going to divide both sides by 64, and I'm going to get 1/4 of a foot equals x. 1/4 of a foot. Well, if I think of my foot being 0 inches, and cutting it in, and here's 12 inches, we'll say, because 12 inches is 1 foot, and I'm going to cut it into 4 pieces. Here's 1, here's 2, here's 3. Let's make 12 down here. There's 4. Then if I was going to fill these in, this would be 3, 4, 8, 12, and 1/4 would be 3 inches. Think about your little Matchbox cars. Are your little Matchbox cars? Ooh, let's see if I can draw one here. Are your little Matchbox cars right around 3 inches long? Yep, we're pretty close. So 1/4 of a foot equals x, which is the same as or approximately 3 inches.